Okay, so today we're going to do 2.2, and that's polynomial functions of higher degrees. So you have to know what it means to be continuous. So in order for a polynomial to be continuous, you must be able to sketch the curve without lifting your pencil. Okay, notice here we talked about curves. Okay, so these are not like sharp points. There shouldn't be any, absolute value looking pieces of your graph. That should be curved and there should be arrows on the end. Okay, so for example, this would be like a continuous curve. All right, I didn't have to lift my pencil at all. It's full of curves and it's a continuous polynomial that way. Okay, we're going to talk about the leading coefficient test. Okay, so this is a test that you have to memorize, all right? But there's kind of an easy way to do it. So this test works for any polynomial function. Let's break our paper up here into like fours, because there's really 4 pieces to this test, okay? So we have even degrees on one side and odd degrees on the other. Okay, so if a sub n is greater than 0 and it's an even degree, so a sub n is going to be like our leading coefficient. Okay? So a sub n is going to be our leading coefficient. When I say leading coefficient, I'm talking about the number in front of the highest degree term, right? So the degree is determined by the highest degree term. So for example, if you have like f of x equals 2x to the 4th, let's say. Okay, our leading coefficient is 2. It's greater than 0, it's positive. And our degree is even. We have a degree of 4. If that is the case, then your polynomial will point up on the left and on the right every time. If you have, I guess let's just keep going with even. If a sub n is less than 0 and you have an even degree. So for example, if you had like f of x equals negative 3x to the 6th, our coefficient is negative, we have an even degree, then our polynomial will point down on the left and down on the right. Okay? So let's go over here to the odd degrees. If a sub n is greater than 0 and it has an odd degree, for example, if you have f of x equals, let's say, 10x to the 5th. Okay, we have a positive coefficient and we have an odd degree power, then that means that it's going to rise to the right and fall to the left. You're really just trying to determine the pattern of the graph. So what we're going to do today is graphing, a ton of graphing, and we're going to graph by hand, which means that the 2-1 to 2-2 quiz is without a graphing calculator. Okay. The last part of the test is if a sub n is less than 0 and you have an odd degree. So for example, if you have f of x equals negative 6x to the 7th, let's say. then you will kind of flip-flop this. So it'll rise to the left and it will fall to the right. So it seems like this is like a lot to remember, but I think you know what x squared looks like and x cubed looks like, right? And you know that if x squared is positive, then it points upward, and if x squared is negative, then it points downward, right? So if you know that, then you know the even test, right? Because it's true for all patterns of even degrees. Just like you know x cubed, the S curve, right? It points up on the right and down on the left when it's x cubed. If I flip it, right, it's a reflection over the x-axis, and then it flips. So it points up on the left and down on the right. So if you know those two patterns, then you know the patterns for all even and odd degree polynomials. Okay? But this is called the leading coefficient test. It's just a little bit more formal. Okay, so we're going to practice that. All right, so we'll call this example 1. Apply the leading coefficient test. We'll just call it the LCT, just to abbreviate, okay? So if I give you f of x equals, I'm just going to give you 3 of them, and then you figure out what they do. And all you have to do is draw the arrows like we just did. So just draw your little axes, and then you're just going to draw arrows to determine what it does on the left and the right. So go ahead and try those. Remember, you're looking for the highest degree term. Okay, so for this first one, it's a positive coefficient, right? And it's an odd degree term. Do you have it rising to the right, falling to the left? For this one, it's the opposite, isn't it? The highest degree term is 3, but it's a negative coefficient. So it should just flip. So this should rise to the left, fall to the right. Now, when you did C, did you notice that the negative 2x to the 4th was actually the highest degree term? This wasn't in standard form. So you have to pay attention to a little thing like that as well. And then that would make this fall to the left, fall to the right. Can everybody do the leading coefficient test? Great. Okay, moving on. Let's talk about zeros of a polynomial. Okay, zeros of polynomial functions. Remember, when you're talking about zeros, you're only talking about the x values. Okay, so if I ask you for the zeros of the function, I am only asking you for the x. So you say x equals 2, x equals negative 5. You don't write it as an ordered pair. Okay, so the degree of the polynomial determines the amount of zeros. So if you have something like to the 5th degree, then you're going to have 5 zeros. If you have something to the 3rd degree, then you're going to have 2 zeros. Okay? Remember, zeros represent the x-intercepts, right? That's what you're doing when you're solving, right? You're finding x-intercepts. And when we ask for just the zeros, you're only talking about the x values. Okay, you ready to try a graph? We're going to kind of put everything together. And a lot of this you already know how to do. So we'll call this example 2. And we're going to sketch the graph. Okay, so let's start out with this one. F of x equals 2x times x minus 1 squared times x plus 2. Okay, I'm going to do that thing where I'm kind of like thinking on the side when I look at this and I'm starting to think about how am I going to go about graphing it. So here's what I'm thinking. First thing I'm thinking is this is nice because this is already factored for me. Okay, so it's in factored form already. Okay, it's already factored. Then I'm going to think to myself, what is the degree? Like, what am I looking at here? What type of zeros am I going to get? How many do I think I'm going to get? So how many zeros would I get there? What is the degree of this polynomial? 4, because we have an x to the first, an x squared, and an x. When you add all those up, you get x to the fourth. So I have an x to the fourth as my, highest degree term. So therefore I have the fourth degree, which means I'm expecting 4 zeros, doesn't it? Now here, that's the maximum number of zeros I'm going to get, by the way, right? You don't have to get 4 zeros because some of them might be imaginary. And so that happens. Also, there's something else going on here. Does anybody know what this piece is? X minus 1 squared. Jamal?
Does that mean once it reaches that point, it goes back the same way, doesn't cross it?
Exactly. It touches at the axis. This is called a double. Okay, this is really important. So this is called a double. Now the double is occurring because we have a squared piece. So that's saying that that x minus 1 is really x minus 1 times x minus 1, which is meaning that x equals 1 is occurring twice, making it a double. So if I was to get all real zeros here, I would really only have 3 different zeros, right? Because this 1 is counting for 2 solutions, okay? So I noticed that there's also a double. And all doubles make a parabola shape at the axis. So Jamal, like you were saying, like it's going to bounce off and go the other way. You're right. It doesn't cross the axis, it bounces off. It forms a parabola shape. So it's things like that you should be thinking about when you're graphing this stuff. You should expect to see these patterns. Let's talk about also what is the leading coefficient. So if I'm thinking about this, I know it's going to be an x to the fourth, but is it a positive? Is it a negative? What's the number? So what would be the highest degree term here? It'd be 2x times x squared times x, right? So that would give me 2x to the fourth. So I'm thinking about that 2x to the fourth when it's time to do the leading coefficient test. All right, so this is what I'm thinking about before I even start the problem. All right, so here's the steps. Step 1, you're going to find the zeros first. Okay, so to find the zeros, normally I would have to factor. I don't have to do that here, though. They're already set up, and I can just use the zero product property and find them. So I have 2x equals 0. I have x minus 1 squared equals 0. And I have x plus 2 equals 0. And then you just use the zero product property. So I get x equals 0, x equals 1, and x equals negative 2. When you list the zeros, I want them listed just like I've wanted everything else listed with multiple answers, from least to greatest. When you list a 0, you also just write the x value. You don't write these as ordered pairs, even though they represent the x-intercepts. Okay? So I'm going to make myself a note here. They represent x-intercepts, and I do have this double of 1, right? So I should see that parabola pattern at the x-axis. Okay? So that's kind of what I'm thinking. Let's move on to the second part. So step 2 is to now conduct the leading coefficient test, or the LCT we're just going to write. Okay, so all you have to do when you do this for me is draw your little axes there. Maybe determine what that leading coefficient is, so that 2x to the fourth is what we're looking at, right? It's got a positive coefficient and it's an even power. What's this going to do? It's going to go up on the left and up on the right, and that's all you have to do for that part. You with me? Okay, so step 3, you're going to find additional points. So you are going to have to make a table. Now, before I make my table, I'm actually going to graph what I have so far. Okay, so I want to see like what kind of values should go on my table, and the only way to determine that is to see what I got going on. So let's just go ahead and do this. So I guess step 3 and 4 really go kind of together. So this is where you're going to actually graph. So to graph this, okay, let's see. Just set up your axes. If you're ever changing the scale to something other than 1, you have to label the scale for me. Otherwise, I'm just going to assume that it's a 1, okay? So what I'm going to do first is I'm going to plot all of those zeros that I have, those X-intercepts. So my zeros were -2, 0, and 1. I'm going to plot those first. So I have -2, 0, I have 0, 0, and I have 1, 0. Okay, so that's the first thing you do. So I don't know if you want to write it down or not, but part 1, we plot zeros. When you're graphing step 2, then you're going to want to think about what kind of values should I choose for my table. So now here's the deal. We're really going to want to find the relative maximum and minimum. To do that, even though it's not necessarily true all the time, we're just going to choose the point that's in between our zeros, okay? It's not always the relative min or max. It could go lower, but that's what we're just going to do as a practice, okay? So I definitely want to choose like -1 for my table. Everybody agree with that? Now between 0 and 1, I'm going to have to choose a fraction. So I'm going to choose a half. If you want to use 0.5, you can on your table, but it's a half, right? So choose halfway points between zeros. What's another point that would be important? Like, wouldn't the y-intercept be important? Now, granted, we can see that here, right? So it was a 0, so it's already done. But if it wasn't, then you're going to want to choose, 0 for your table as well, for sure. That's important, okay? What else do we want? So now I know kind of what's going on the in-between, but what don't I know? The left and the right, the ends, right? Now I know that it's going to go up on both the left and the right because that's what my leading coefficient test told me, and you better verify that once you're done. But I got to choose something. So I will choose like 2 and -3. You could choose -6 and 20 if you wanted, okay? But I want to work with smaller numbers. So I'm going to choose like -3 for my table. I'm also going to choose -1, a half, and 2. Now, on your quiz, I'm going to set it up like this. So I'm going to have a place for your zeros, your leading coefficient test, your additional points. You might see 20 blanks in your table. You don't have to fill in all those points, right? We just need enough to show the full pattern of the graph. All right, sound good? So then I guess finally choose points on left and right. Okay, so now we're going to go back to the table. So you do understand when we are finding the table, we're plugging it into the original function, yes? Right, and you're evaluating, and I'm assuming that you know how to find table of values. Is that a fair assumption? We're just going to fill this in then, okay? So -3 gives us 96. -1 was -8. 1/2 is 5/8, and 2 is 16. Okay, so now step 3 on this graph over here, we're just going to plot our table, and then we have to label, and that's where we're going to talk about what I expect for a fully labeled graph. Okay, so we have -3, 96. Now, I don't expect you to really go to 96 on our scale, okay? If you want to change the scale, you can, if you want to count by something else, but I'm really okay if you just put a point up here and label it -3, 96. Okay, I'm fine with that. So we were at -1, -8. So I just got to extend this a little bit. That has to be labeled. Okay, so our relative minimum that we're going to call our relative min has to be labeled. This 1/2, 5/8 is like here. That one needs to be labeled. And then we have 2/16. And again, that's going to be kind of, you know, up here somewhere. So we'll just throw it here. Okay? I'm really not particular on those, you know, bound points where it's really extending to infinity. It's more the relative maximum that I'm looking for. Okay, so now what you should notice here, right, we talked about the fact that this was a double, right? So you'll notice it's not dropping back down here, right? It's got to rise to the right. So it bounces off the axis and it comes back around. So that's how you know this is a double, looking at the graph. It forms that parabola shape bouncing off the axis. Okay, we want arrows on both ends of our graph, and then we have to label the function itself. So f of x equals 2x times x minus 1 squared times x plus 2. Okay, so when I expect a fully labeled graph, I'm expecting the following. A scale, if other than 1. I'm expecting all of your max and min points. So relative, max, and min, or mins, or maxes, okay? I'm expecting the function and arrows, okay? These points, they're not necessarily a relative max or min, but kind of just showing me that it's, you know, extending to that point. So it's not a bad practice to get into to label everything. Okay, notice I didn't label my X-Intercepts. I can see those, okay? And as long as you're counting by a scale of 1, I know those are correct. Okay? Do you understand what it takes to have a fully labeled graph? This graph would get full credit. Okay? All right, want to make sure that expectation is clear. So, why don't you try one? I'm going to give you one, and then you're going to try. We're going to walk through these steps. And I guess I'll just pause the video. So, or you want to just do it together since I'm recording? Okay. Sorry, everybody that's listening. All right, so this is well, I guess we're still on example 2. B. This is B. So f of x equals negative 4x cubed plus 4x squared plus 15x. Okay, so this one is a little different at the beginning because it's not factored anymore, right? So when we go to find the zeros, we're going to have to factor, all right? Can you see the leading coefficient? Yes, right? And that should be this one here, this negative 4x cubed. Okay, so we can see that, and now we're ready to kind of start. So remember, I'm going to ask you for those 3 steps. So step 1, we're going to find the zeros. Now, in order to find the zeros here, we're going to have to actually factor this, right? So we're going to set this equal to 0, negative 4x cubed plus 4x squared plus 5x equals 0. And now I am ready to factor it. Oh, thank you so much, 15x. Okay, so now I'm ready to factor. So what can I take out? I can take out an x. I'm also going to take out the negative with it because I really hate a negative leading coefficient. So I'm going to factor out that negative x. And then this is going to give me a 4x squared minus 4x minus 15 left over. Okay, now I got to factor using guess and check. Okay, so I'm cheating because I know the answer. Okay, but we're going to do 2x plus 3 times 2x minus 5. So you'd have to use guess and check or your box method there in order to get there, right? Okay, so now we're ready to use the zero product property. So I'm going to take each piece, set it equal to 0. We know how to do this. We've been practicing this a lot. So I get x equals 0, negative 3 halves, and 5 halves. But because I wasn't smart enough to order them in the first place, I got to rewrite it. So just rewrite it so that they're in descending order because it's a lot faster to check. Okay, so there are my zeros. You do not list them as ordered pairs. They are just the list of x's, okay? Step 2, we're going to do the leading coefficient test. Okay, so again, I identified that leading coefficient as a negative 4x cubed, so I'm just going to make note of that. All I have to do is draw those axes in and then think. So this negative 4, okay, think about the negative and think about the odd. What's it going to do? It's going to fall to the right, rise to the left, right? So it's going to rise here and it's going to fall here. Does the opposite of what x cubed does because you reflected it. Okay, step 3 is going to be to find those additional points. So again, you're making a table of values. Maybe you'll have 4 points on there, maybe you'll have 10 points on there. Whatever it takes to show the full graph is what you need to have on there. Okay, so let's go ahead and plot what we have. So step 4 is to graph. So we're going to go ahead and plot what we have and then try to determine what values we want for those max and mins. Okay, so I have negative 3 halves 0, 0, 0, and 5 halves 0. Okay, now here's the deal. Notice that I'm no longer at one of those tick marks, right? So now I got to label the x-intercepts. Okay, so you got to label these. So this is negative 3 halves 0 and 5 halves 0. 0, 0, I'm good. I don't have to label that one. Okay, now what kind of values do we want to put on our table? Would you agree we want to choose a negative 2? Maybe, or negative 3. So I'm going to put negative 2 there. Okay, between, this will be fun, between 0 and negative 3 halves, what is the halfway point? 0.75, negative 0.75 or negative 3/4, so that one's going on there. Okay, how about between 0 and 5 halves? 5/4, so 5/4 has got to go on there. And then maybe 3, right? It's the next one over. We got to choose something to the right. You could choose 3, 4, 5, 20 if you wanted. It doesn't matter. So I'm going to pick 3. Okay, so I feel like students always struggle. What points did you put on the table? You just got to follow those rules. Pick something on the left, pick something on the right, and then pick the in-betweens. Yeah.
So halfway point literally means the halfway.
Literally halfway between them.
You can't just pick like that.
No, because we're going to call that our relative max or min. Now, technically, it could go lower, it could go higher, but that's what we're just going to do, okay? You can choose more points in between there, too, but I am going to require the halfway way. Okay, so now, is it okay if I just give you these? Okay, so for negative 2, we were at 18. Negative 3/4 gives you negative 7.3125. Oh, there's a decimal. That you will like that. 5/4 was 17.188, and then 3 was a negative 27. Okay, now we got to just label this stuff. So negative 218 is going to be, pretty far up here. So we'll just label that negative 218. Negative 3/4 and negative 7. Like down here somewhere. So negative 3/4, negative 7.3125. Let's see, negative 3 or positive 3, negative 27 is going to be way down here. And then 5/4, 17.118 is going to be right here, let's say. Okay, now I realize that our Y scale is not really accurate, but we have our points labeled, so it's good enough. Now, when you graph this again, you're showing curves, so you just keep that continuous movement with your pencil or pen. Okay, here's our graph, and then we want to label it with our original. F of x equals negative 4x cubed plus 4x squared plus 15x. And I guess we could say here, I probably should have done that a little nicer, but if we did 3, 6, 9, 12, 15, 18, it's pretty close. Maybe you counted by threes. Down here I should have probably had my thing here. So maybe let's bring this up here, just to make it nicer. more accurate. So 3, -3, -6, -7. And I'll wipe this out. Okay, just ignore this piece. That is a little bit more accurate, looks nicer. Okay? So those are really the 3 steps. Okay, this is a fully labeled graph. It's not tough, right? You know how to do all these pieces. Really the only new thing is the leading coefficient test, which you really already know. Now here's what I'll tell you. Students, this is what happens. They'll do the leading coefficient test correctly. Then they'll come down here when they're making the table. They'll screw it up. They'll evaluate wrong. They'll put the wrong points here. And then their graph will point down on the left and up on the right. And you'll never think to check that. Please compare with the information that you got here, right? If you know that it's supposed to point up on the left and down on the right and it doesn't, then go back and look at your table. Your table's probably wrong, okay? If you know that there's supposed to be a double here and it's supposed to form that parabola shape and it doesn't, it crosses through, then you've done something wrong and it's probably your table. The table is where most people screw up, okay? So this is 2.2. That's it. You okay? Okay.